Hello, good afternoon. Today I'm going to discuss about the more points on the Gprs security. So Gprs attempts to reuse the existing GSM network elements as much as possible, but to effectively build a packet-based mobile cellular network, some new network elements, interface and protocols. So these are the elements in this mobile station MS. Or the new mobile station is required to access Gprs services. Then your BTS. A software upgrade is required in the existing BTS, that means base transceiver station. Then BSC, base station controller, requires a software upgrade and the installation of new hardware called the packet control unit PCU. Next is your Gprs support nodes. The development of Gprs requires the installation of new core network elements called the serving of Gprs support node SGSN and gateway Gprs supported node SGSN. Next is your database, that means HLR, VLR. All the database involved in the network will require software upgrades to handle the new call models. Next is your Gprs support nodes. Following two new components called gateway Gprs support node GSN and serving Gprs support node SGSN are added. Gateway Gprs support node first GGSN. The gateway Gprs support node acts as an interface and a router to external network. It contains routing information for Gprs mobiles, which is used to tunnel packets through the IP-based internal backbone to the correct serving Gprs. Next is your serving Gprs support node SGSN. Supports node is responsible for authentication of Gprs mobile, registration of mobiles in the network, mobility management and collecting information on charging for the use of the air interface. Next is your internal backbone. The internal backbone is an IP-based network used to carry packets between different GSN. Tunneling is used between SGSN and the GGSN system. Next is your routing area. Gprs introduced the concept of a routing area. This concept is similar to location area in the GSM, except that it generally contains a fewer cells. Next is your Gprs mobile station classes. In order to take advantage of the new Gprs services, we need new Gprs enabled handsets. As usual, there are different types of handsets, class A, B, C. And the class A terminals can manage both packet data and voice simultaneously, which means one needs two transceivers as the handset has to send or receive data and voice at the same time. This is the main reason why class A terminals are high priced to manufacture than class B and C. So in the class A Gprs system, that means at a time you can attend the voice call and also the data. The packets are also available, but in class B terminals do not play the same role like class A. These terminals can manage either packet data or voice at a time. Similarly, for example, if user using the Gprs session, then this session is halted if 1C receive a call. This is a class B type, and the class C terminals can manage either only packet data or only voice data. That is only one. What is the example class C terminal are Gprs PCM CIA cards, embedded modules in vending machines and so on. Next is your Gprs protocol stack. The flow of Gprs protocol stack and end-to-end messages from MS to the GGSM is displayed in the below diagram. And the subnetwork Dependent Convergence Protocol SNDCP and Logical Link Control LLC combination used in between the SGSN and the mobile station. The SNDCP flattens data to reduce the load on the radio channel, and a safe logical link by encrypting packets is provided by LLC, and the same LLC link is used as long as mobile is under a single SGSN. Next is your SNDCP, Subnetwork Dependent Convergence Protocol. The main function of SNDCP are transmission and reception of NPDUs in acknowledged and non-acknowledged LLC mode, multiplexing of several PDP. Next is a convergence from different protocols to single link supported by LLC. Segmentation and reassembly of network packets to or from LLC frames. Header compression or decompression of user data. Segmentation of a network protocol data unit NPDU into LLC protocol data units LLPDU, and reassembly of LLPDUs into an NPDU. Next is your logical link control LLC. It establishes a link for packet transmission between MS and SGSM. It may either work in acknowledged or unacknowledged mode of transmission. Next is your GPRS tunneling protocol GTP. GPRS tunneling protocol GTP is a group of IP-based communication protocols used to carry general packets radio service GPRS within GSM, UMATS and LTE network. In 3GPP architecture, GTP and proxy mobile IP-based interfaces are specified on various interface points. GTP can be decomposed into separate protocols GTP-C, GTP-U and GTP. So GTP-C just a minute. Okay, GTP-C is used within the GPRS core network. GTP-U is used for carrying user data within the GPRS core network, and GTP prime uses the same message structure as GTP-C and GTP-U. Next is your mobility management GPRS. GPRS states model. The operation of a GPRS mobile is characterized by its three operational static: initialization or idle state, standby and ready. First is initialization or idle state. When the mobile is turned on, it must register with the network and update the location register, and this is very similar to that performed with a GSM mobile, but it is referred to as location update. Next is your standby. The mobile then enters a standby mode, periodically updating its position as required. It monitors the MNC of the base station to ensure that it has not changed base station, and also looks for stronger base station control channels. Next is your ready state. In the ready mode, the mobile is attached to the system and a virtual connection is made with the SGSM and GGSM. By making this connection, the network knows where to route the packets when they are sent and received. In addition to this, the mobile is likely to use the PTCS to ensure that its timing is correctly set to, so that it is ready for a data transfer should once be needed. And this is the GPRS actual sending data process, and this is the Gprs applications. First is your chat, multimedia service, and is your virtual private network, VPN or VSAT, personal information management, and vehicle positioning. Next is your Gprs limitation. There are some limitations with Gprs which can be summarized as: limited cell capacity for all users, only limited radio resources can be deployed for different users. Both voice and Gprs calls use the same network resource. Next is your speed lower is reality. Achieving the theoretical maximum Gprs data transmission speed of 172.2 kbps require support of Gprs mobile terminate connection for a mobile server not supported. As of date, a Gprs terminal can only act as a client device, and there are many services for which server has to be mobilized. That means this is the limitation of Gprs. And for today this much, and from tomorrow onwards when we discuss about the IS-95 and other new concept. So thank you to all.